Assessing thermal efficiency of a building using RETV analysis. Abstract: India is a developing country with a huge population, which means our need is only going to be increasing. The residential floor area is going to be doubled and the energy consumption tripled. Around 34% of the energy in the housing sector is consumed just for heating, cooling and ventilation of the building. The increase in global warming is causing a drastic change in the environment and the atmospheric temperature. This is causing an increase in the demand of AC and heaters. This brings the question of what should be done. One way out is to increase the thermal efficiency of the building envelope. When the thermal efficiency is increased, the temperature outside will not affect the inside temperature to a large extent. It also improves the lighting and ventilation of the building. India never had a code for the building envelope until in 2018. Eco-Niwas Samitha 2018 was launched to maximize the RETV value for a building. So, this project would also like to increase its awareness in the society and also develop different methods to include it in during the planning and construction of a building. Keywords: RETV, thermal efficiency. Introduction. The residential building floor area may be increased from 16 million m2 to 31.6 million square meters, due to which under Pradhan Mantri Awas Yojana 20 million new homes are planned to be built. Thus, increasing the residential energy consumption, it is estimated to be increased from 246 TWh/Y to 748 TWh/Y by 2030. Approximately 34% of the energy is used for the cooling or warming the building, thus anticipating the rise of AC usage from 8% to around 21% and 40% in 2027-28 and 2037 to 38 respectively. Therefore, improving thermal comfort in buildings is very important, which helps in minimizing the cooling energy needs in residential buildings. The new Energy Conservation Building Code for Residential Buildings, ECBCR, in the Eco-Niwas Samhita 2018, B. 2018, provides the following provisions. 1. To minimize the heat gain in cold climate or heat loss in hot climate. 2. For natural ventilation potential. 3. For daylight potential. Building envelope is the barrier which protects the interior of the building from the outside environment. This mostly deals with the design and construction of the exterior surface. The external envelope design and the material used in the construction should include the climatic conditions, structurally sound and aesthetic. These elements are the major factors in constructing the building envelope. The building envelope comprises roof, subfloor, exterior doors, windows, and of course the exterior walls. The net heat gain rate through the building envelope of the building, apart from the roof, divided by the area of the building envelope of the building is called residential envelope transmittance value, RETV. Its unit is W/m. The RETV includes the area of opaque, area of non-opaque, the SHGC value of non-opaque, the U value of the material, the orientation of the building and the location of the building. By doing this we are including the conduction of heat through the opaque and non-opaque surface, convection of heat through openings and heat radiation through the non-opaque surface. 2 objectives. To identify and select a building on which the analysis shall be carried out. To understand the thermal efficiency of the building using RETV analysis. To compare the value with the standard RETV values mentioned in the code. To suggest suitable modifications to achieve the optimal thermal efficiency value. 3. Present investigation. The selected building for the case study is Habitat Illuminar for the case study. It is situated in Bangalore, which has a temperate climate. The total area of the project is 4.5 acres. The built-up area is 6 lakhs 50,000 sq. There are 10 blocks. The 10th block is selected for the analysis. The tower has B+G+11 floors. The built-up area of the block is 45,000 sq. It has one set of 2-bedroom house and one set of 3-bedroom house on each floor. Material. U value, W/m2. For the current investigation, Energy Conservation Building Code Residential, ECBCR, Compliance Check Tool. ECBC tool. The Energy Conservation Building Code Residential, ECBCR, compliance check tool is used for the analysis of the selected structure. It provides the project proponent complete virtual assistance in the form of an easy-to-use and interactive user interface for evaluating code compliance of the proposed residential building design. It takes the construction details of various building envelope elements such walls, roofs, windows, ventilators and doors as input in dedicated forms, and based on the user inputs the code compliance is evaluated. This gives us the RETV value, the U-roof value, VLT% and the window to floor area ratio. We have provided the necessary inputs about the building. Table 2. Final results for the current building. 1. Window to floor area ratio, WFROP. It is the ratio of appendable area to the carpet area of the dwelling units. From the Energy Conservation Building Code Manu Alpha Composite Climatic Zone, minimum percentage of window to floor area ratio is 12.5% and the calculated value of the project is 8.12%, which is non-compliant 0.2.46. 2. Visual light transmittance, VLT. The amount of light in the visible portion of the spectrum that passes through a glazed material. Higher the VLT, more is daylight received inside the building through glass. From the ECBC manual, the minimum value of VLT is 27% and the calculated value of the project's VLT is 62.17%, which is compliant. 3. Thermal transmittance, U value. It is the rate of heat transmittance through materials. The lower the U value, the lower is the heat gain/loss in the building. From the ECBC manual, maximum U value is 1.2 and calculated value of the project's U value is 2.75, which is non-compliant. 4. Residential envelope transmittance value, RETV. From the ECBC manual, the RETV of the building envelope cannot be higher than RETV of 15W/M2 and the calculated value of the project's RETV value is 13.27W/M2, which is compliant. 4. Results comparison with different materials. After a study on the different materials that can be used in the building envelope construction and the RETV analysis was carried out using the different construction material for the same building. The below are the data that is received after the calculation of the values using ECBC tool. This helps in understanding the effect the material has on the thermal efficiency of the building. The analysis helps in choosing the best material for the construction. Method of analysis. The present study deals with two types of analytical software. A.Carbs tool. B.Equest software. A.Carbs tool. Center for Advanced Research in Building Science and Energy developed a free online tool for thermal transmittance or thermal conductance, U value, for the wall and the roof. The tool can be used for selection of building material, for building energy modeling and analysis. This tool is supported by Ministry of New and Renewable Energy, Government of India. By entering the location, assembly type, material of the wall and thickness of the wall, this tool provides U value of the assembly by using static and dynamic methods and thermal properties of individual layers. B.Equest software. Equest is a USA-based software which is used to analyze the building energy, which gives professional level results. It also allows the user to get the detailed analysis of building design technologies using building energy simulation techniques. This also helps in easy 3D modeling of the building. The below is the 3D model output from the Equest software. The 3D model clearly shows the shape and the different zones of each floor. The model has been created by using two different types of shell, I.E for the ground floor and for the remaining floors. Because of the use of floor multiplier, the floors from 3rd floor to 10th floor is not visible, but the software takes these floors also into consideration. By using floor multipliers, space in the memory can be saved and also reduces computation time. Fig 3. The final model. The total energy consumed by the entire unit is 365,130 kWh. This is calculated based on US standards. From the below table and the graph, the maximum electricity is consumed by the space cooling, ventilator fans. The electricity consumption value is high during the summer and the value is less in the winter. This is because of the outside temperature. See using different U values and getting the respective electricity consumption. The same simulation was performed using different materials by changing the U value in the wall construction details. The below is the graph which shows the U value and the electricity consumption for different materials. Fig. 5. Comparison of U value and corresponding electricity consumption for different material. D. Electricity bill calculator. This is a free government tool to calculate the monthly electricity cost. It is calculated by dividing the annual electricity consumption of the building equally for all months in a year. By selecting the state, district, and electricity supplying company, then by specifying the monthly electricity consumption, phase, single phase or three-phase, and the sanction load, the user will be able to calculate the electricity cost. The table below gives information about the type of bricks used and the annual electricity cost of the same building if the walls are constructed entirely by specific type of brick as mentioned in the table, by using a government tool called as Online Electricity Bill Calculator. The annual electricity cost for different materials can be calculated by inputting their respective electricity consumption values in the tool. From the table, if aerated autoclave concrete blocks instead of fly ash bricks for constructing the wall, then this can save an annual electricity cost of Rs 2,66,592, thus reducing the operational costs of a building. Conclusion. The main intention of the project was to understand the importance of RETV value and how the value plays a significant role in understanding the building envelope efficiency. The research from the project helped to draw the connection between RETV value, U value, and electricity consumption. This helps in showing the importance of the material used in building construction and the thermal transmittance of the material. From the above tool and analysis, we can conclude that higher the U value, lower the RETV value, which means that the thermal insulation of the building material is good. If the thermal insulation is high, then the influence of the outside temperature on the inside is less. Therefore, this reduces the cooling/heating load, thus reducing the electricity. The importance of other parameters like SHGC value, the building orientation, which plays a huge role in determining the REVT value, is also understood because of the results from the project. If RETV analysis is implemented in everyday construction, about 20% of cooling energy and 25 million kilowatt-hour electricity can be reduced, and also reduce 100 million tons CO2 of released in the atmosphere. The values are taken from B website. This is the main point to take away from the project. The amount of change it brings about in our daily life by changing material used in construction and design changes.